This is Team L with the Hayward Bypass Valve Optimization Project. We wanted to make sure we could reduce the pressure loss from a bypass valve inside of a Hayward pool heater. The heater itself only needs 30 gallons per minute flowing through it. Anything else higher than that from the pool pump needs to be bypassed around safely. We started off the semester by building an apparatus to test these valve designs. So we start off with a pump, pumping it through a bunch of pipes into some pressure sensors to test the delta P through a flow sensor so we could track our flow rate, and then back into a big 55-gallon drum to act as the pool itself. You can see here the graph from Hayward of the two valves they tested, their old one in yellow and their new one, the blue line up top. Their goal was to get the new one, the blue line top, to have a flatter curve, especially around the 30 gallons per minute mark. It should just open and stay pretty flat. Once we had built our whole apparatus and had it running, our next goal was to create our own custom spring rates, tested different shapes and sizes, and then did a bunch of calculations for our spring rates to try to find the most optimal size to open at 30 gallons per minute and reduce that pressure loss. Since the apparatus Hayward used to test their own valve was a lot different than the one that we built, we ended up with much different results for the same valve. You can see here the yellow and green lines. So we added a correction factor to the table so that those would be 1-to-1 as they should be, and here are the results of that. You can see our two custom spring rates towards the bottom, the orange and light blue line, have achieved our goal of majorly reducing the pressure loss in the system, gaining only 4 psi from 30 gallons per minute all the way up to 105 gallons per minute.